For doing transient analysis, it is important to understand some basic facts. Like, suppose if I am having a capacitor and there is also an inductor. When initially, when initially current is passing through a capacitor, the capacitor will allow the current to pass. So it will act like a short circuit. Whereas an inductor will not allow initially the current to pass, it will oppose it. And that's why initially the inductor will act as an open circuit. Now it does not mean that the capacitance is not there, or the capacitance is taken out from here, or in this case the inductance is not there and the inductance is taken out from here. No, all it means is that initially the capacitor will not allow current pass through it, will allow the current to pass through it, so it's like a short circuit, whereas the inductor will not allow the current to pass through it, it will oppose it, so it's like an open circuit. Now after some time, when the capacitor is slowly charged, okay, then we will say that as the final stage. So what is the final stage? Final stage is when the capacitor has completely charged or the inductor has completely charged. In that final stage, after the capacitor has charged, no current will pass through the capacitor anymore. So the capacitor will start acting like a open circuit. Whereas once the inductor is charged completely, it will no longer oppose the current that is passing through the inductor. So the inductor starts acting like a short circuit. This we have to understand for understanding the behavior of inductor and capacitor with respect to time. So when initially some power source is connected or some current source is connected, the capacitor will act as a short circuit. After it is charged, it will act as an open circuit. Remember, it does not mean that the capacitor is not there, the capacitor is still there. Similarly, the inductor initially it will act as an open circuit, but later it will act as a short circuit. It does not mean that the inductor is not there, the inductor is still there. So after charging, how will the inductor look or how will the capacitor look? So after charging, the capacitor will basically look. So initially the capacitor was not charged. Now the capacitor will look like the capacitor is there, but there is a charged up voltage source. That source will have a polarity as plus and minus. Plus and minus based on what? Based on which direction the capacitor was charging. That means if suppose the capacitor was here and the charging current was flowing from top to bottom, then this capacitor charges like plus minus. So that same polarity we are having here. So after charging, the capacitor will have a voltage source with it, and that voltage source will have a voltage which is V0 divided by S. Now what is V0 voltage? V0 voltage is the voltage at which the capacitor is charged. The capacitor is charged. So that is the voltage. How do we find out this voltage? That I will tell later. So After charging, the capacitor looks just like this, that it's a capacitor having a value S 1 by SC, and the voltage source is V naught by S, where V naught is the voltage at which the capacitor has charged. Now you might be asking, what is the voltage at which it is charged? See, I told you here that the capacitor after charging becomes open circuit. So whatever is the voltage across this open circuit, that voltage is the voltage up to which it has charged. So that voltage is what we are going to write here, and it is important to find that voltage to do the problem. Now what about inductor? Inductor similarly is having a charging current flowing through it. Initially it is open circuit, later it starts conducting and it becomes a short circuit completely. And the inductor can be represented as, after charging, it is an inductor but with a source. But remember, this source is having an opposite polarity to the direction of current flow. That means if the current was flowing like this, we will think that okay, this should be plus and this should be minus. No, that opposite of that is the polarity here. Why? Because the inductor opposes the current. So here we are having, after charging, the inductor like this, where the value of this voltage is given by the inductance L multiplied with the current I0 or I0 minus, and the inductor here is represented as Ls or SL. Now here L already we had obtained. How or what is the value of I0? I0 is the current up to which the inductor is charged. The L is charged, up to which the L is charged. How do you find out that current? Well, that current you can find out, or up to what current the inductor has charged, that value you can find out by looking at what happens to the inductor at the end of charging. At the end of charging, it is a short circuit. That means some current is flowing through this short circuit. That current is the current up to which it has charged. So the capacitor charges to a voltage, the inductor charges to a current. Based on that value of voltage, you get the what is the voltage to be added up with the capacitor, and with that current you get what is the voltage to be attached to the inductor. So whenever we have a problem, we do it in two parts. Part 1 is done to find out V naught or I naught based on charging, how much the capacitor has charged or the inductor has charged. Based on that, we will try to find out what is V naught, I naught. And then there is a second part. The second part is, instead of capacitor, you draw the capacitor with a voltage source if that capacitor is charged. If the capacitor is not charged, then you won't draw this voltage source. You will simply keep the capacitor. And you will, instead of inductor, if it has been charging, then instead of the inductor you will have an inductor plus a voltage source Now this will be there only if the inductor has been charging. So you will replace the capacitor with this circuit, you will replace the inductor with this circuit of inductor and voltage source, and you will carry out whatever is the value you want to find out. You will either do mesh analysis, or you will do nodal analysis, or you may use theorems, that means either Thevenin's or Norton's or superposition. Any of this you will use to solve the circuit to find out whatever is the unknown element that is there. So let's do a question based on transient analysis.